Hey everybody, welcome back to the garage. If this is your first time visiting my channel, please go ahead, click on subscribe, and also click on the bell to receive all the updates and activities on my channel. So for today's project, we're going to be working on the Polaris Axys 800. So specifically what we're going to be doing today, we're going to be replacing these guys right here. These are the motor mounts that Polaris uses on the 800. So the reason why we're replacing them is I bought this sled about a month and a half ago. And one of the first things I noticed at idle, there was a lot of vibration in the footwells. You could actually see the skis vibrating back and forth, as well as the front bumper. And a lot of these symptoms are actually related to the failure of these motor mounts that Polaris uses on the 800. So when the Axys chassis was released in 2015, one of the marketing things was, lower center of gravity and everything else, because they changed the motor mounts to drop the engine further down in the bulkhead, which resulted in a lower center of gravity. So a lot of the issues that we're going to talk about are because of the design of these tiny motor mounts. These motor mounts do have a tendency to fail, some sooner than later, depending on the miles that are put on the sled. So what we're going to do is we're going to break out the whiteboard. I'm going to give an explanation of why these failed and why you need to replace them. And once that's done, we're going to actually go through the process as far as what you need to do to replace them. It's a fairly easy process with some basic hand tools. So with that being said, why don't we go ahead, break out the whiteboard, and start talking about why these things fail. So in 2015, when Polaris came out with the Axys chassis, one of the marketing things was lower center of gravity and everything else. So what Polaris did is they lowered the engine in the bulkhead, and say this is the bulkhead, right? And what they did is they took the engine and they dropped it down as far as they could. So traditionally, they used motor mounts that were straps that went across the engine, and then there were attachment points that came through the bulkhead and cinched it down. So with the Axys, what they did is, so here's the bulkhead again, right? What they did is they lowered the engine into the chassis, and the way they achieved that is they got rid of the straps on both sides, and what they did is they put the mounts on the sides of the engine, right? And two per side. So in essence, what they allowed to do is the engine was allowed to sink further into the bulkhead, dropping the center of gravity. So because of the design, instead of the load being supported on the straps and on the belly pan, well, not on the belly pan, but on the straps and on the bulkhead, now all the weight is being picked up on the sides of the engine on the PTO and mag side. Okay, so we'll talk about why that's contributing to these mounts. So if we look at a top-down type of view, here's the secondary with the jack shaft, and here's the motor, right? Well, there's a primary, there's a PTO, right? And that's the engine. So now you have your mounts, right? Here, 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 and here. Okay, so what's going on is there is a torsional load that is being applied to the engine. So what happens is, there's just the belt. Whenever the engine is engaged in an RPM, there is a torsional load that is going this way towards the secondary. Polaris knew this, so what they did is they essentially aligned the engine in the bulkhead in a sort of way, and this is the center line. This is exaggerated for the purpose of demonstration, but the engine is actually kicked off by a couple of degrees, and Polaris knew this because when the clutch engages, they knew that there was going to be a torsional load being applied back to the secondary that's going to essentially bring it back in the center line, right? So what happens is, and let's kind of erase this, make it a little bit more clear. So again, here's your clutch. All right. So what happens is when the force is applied in that direction, there's a torsional load on these mounts, which are basically driving them this way, that way, and on the magneto side, they're being applied in the opposite direction, right? And some may ask, why is Polaris using two different types of part numbers for either side? And the reason is there's going to be more movement on the PTO side versus the magneto side because of the load that's being applied. So because of that, that's why these are harder. Okay? And that's why the magneto side is softer. Because Polaris knew when the motor was going to shift that these mounts needed to be harder to basically accommodate for the load that was going to be applied to it. And that's why, because there's more of a movement on the engine on the PTO side versus the magneto side, because essentially the magneto side is just acting as a pivot, whereas the PTO side is the force that's being applied. So that's one load that's being applied to it. That's called a torque load on it, right? So then there's a secondary load that's being applied to it at all times, even when the engine is at rest. So again, this is the engine sitting in the bulkhead. And again, those are the engine mounts. So at all times, even at rest, there's always a static load going down, right? And essentially that's the weight of the engine applying a load even when the engine's at rest. So what happens is over time, because of that static load, those engine mounts, which are acting as a spring, right, are just essentially, they're wearing away down at the bottom because of the static load just by sitting there. What will happen is these engine mounts collapse, and eventually what will happen is they will become egg-shaped, right? Down here on the bottom, and we'll show that when we pull the actual the sled apart, you'll see that there's an up and down movement when a force is applied on the bottom of the engine, causing the engine to go up and down. Okay, so again, if we look at the design of the mount, it's shaped like a gear, right? The gear, but it's also acting as a spring, because again, when Polaris knew that there was going to be a torsional load being applied to it, either in that direction or in that direction, they knew that that motor mount needed to give in such a way to allow the engine to basically move in the bulkhead. If they did just a solid mount, right, it would not allow the engine to move. And what would happen is, if they made that a solid mount, you would get a lot more vibration and harshness being transmitted through the bars, through the footboards, and everything else. Because they made this like a gear, again, this actually acts as a spring. So what will happen is when the torsional load is applied, either left or right, depending on what side, these cogs, or whatever you want to call them, are going to collapse, right? And they're going to compress, which will allow the engine to move left or right, right? To allow for the engine to move, right? So because of this, between the torsional load left and right, and then you have your static load that's always being applied and a downward force, that's why these mounts are always failing. The second issue with these mounts is there's not enough surface area for these mounts to carry the load that's being asked to them. It's just a bad design. Because if you look in the new 850, right, the marketing team from, the marketing that's being applied on it is saying this is the engineer's motor, they did it the way they wanted to. So with the 850, if you look at the mounts, Polaris is no longer picking up the load from the sides because they realize what the issue is, and now they are now picking up the load from the front and back of the engine. Still a lower center of gravity, but they're no longer doing the mounts on the side. They're now picking up the load front and back, so they can stabilize it a little bit better and change the design of the mount. I hope this helps explain the reason why these mounts fail. So with that being said, I know this was kind of long. Why don't we actually go into the sled and start replacing them. To get access to the mounts, we have to remove the bodywork, and this is pretty easy on these Axys sleds. All you have to do is unloosen this quarter turn right there. There's one right there, and then remove the rubber strap. Do that on the corresponding sides, and the covers will pop right out. Now that the side covers are removed, all you want to do is to take the hood off. There's 2 quarter turn fasteners. There's one right there. There's one on the corresponding side, which is right there. And then the last thing you have to do before you can remove the hood is disconnect your cable for the speedo. And all you do is you just press on that clip, and then it will separate. All right, so now we want to remove the muffler. The muffler is held on by 3 retention springs. There's one right there, there's one right there, and then there's one right there. Go ahead and pop those off, and then you can remove the muffler. All right, so we have the muffler removed so we can get access to the mounts and kind of explain what's going on. So you got the recoil housing right there. You have the mount on the left right there, and then you have the other one right there on the right. And all we're going to do to really emphasize, to show how bad this is, we're just going to take a pry bar, we're going to stick it underneath the recoil housing, and with not even that much force, just pulling down with my index finger, you're going to see how bad it is. So if you look, as I'm pulling down on the pry bar, you're going to see how much the mounts are swimming in there, and this is all contributing to the vibrations and everything else. So these mounts are definitely bad, so why don't we go ahead and start pulling them out and replacing them. Okay, so these motor mounts are held on by a 8mm hex bolt. All you're going to do is just use an 8 extension on your ratchet. Go ahead and break them free, and then just go ahead and take them out. It shouldn't be that tight, and we're going to do these one at a time. There's no benefit of doing all at once. So all you're gonna do is you're just gonna break them out free, back the bolt out, pull the bolt out, and then you can pull the mount out. So to make it a little bit easier, get it in there, just grab a magnetic stick, put your new mount on there, and then you can just guide it into the hole, get it started, and then move your stick, and then put the mount in and reinsert your bolt. So what we'll do is we'll come back and torque these to spec, but go ahead and we're going to do the one on the other side, doing the same process. Okay, we're on the clutch side now, and to get at both of these mounts, the primary needs to come off. So we're going to go ahead and remove the primary. Go ahead and stick your favorite anti-rotation device into the clutch. Make sure the kill switch is engaged so this thing doesn't automatically start in the event that the clutch gets away from you. And then go ahead, loosen up the bolt, and then you're going to install your Polaris clutch puller. Now this particular puller has been the same since, I want to say, the year 2000. Once you have your clutch puller fully in, go ahead and take your rotational device, take an impact gun, and then it comes right off. And then go ahead and remove the primary. And while you're at it, go ahead and take the belt off as well. Now with the primary removed, we have access to the mounts on the side. There's one right there, and the other one's right there. And we're gonna do the same process as we did on the magneto side. We're just gonna do one at a time and go from there. So once you have both mounts installed, go ahead and torque them down to the final spec. And the spec is 40 foot-pounds. Before you install the primary, just give the this area a visual inspection. Make sure that you don't have any oil seepage or anything like that. This side looks pretty good. Normally you would take off the secondary to grease the bearing on the jack shaft as well as the drive shaft. For whatever reason, which I don't understand, Polaris removed those fittings, and there's no way to service those bearings as far as greasing them, so there's no reason to remove the secondary at this point. So what we're going to do is we're going to go ahead and put the primary back on. And a little tip, when you put on the primary, you don't have to put any type of anti-seize or any type of grease on the crank stub. This needs to go on dry, because if you do put on some type of anti-seize or grease on this crank stub, what will happen is this will actually heat up along with the clutch, and sometimes that will actually cause it to weld itself, and you won't be able to get it off. So just go ahead, hit it with some brake cleaner, clean it off. Do the same thing with the mating surface on the clutch, and go ahead and reinstall it. With the clutch installed, go ahead and torque it down to 80 foot-pounds. Again, using your holding device. And what you'll want to do is, after you run the sled, you're going to come back and essentially recheck that and retorque it. Alright, so there you go. Takes about an hour to do this. Very easy to do, just using some simple hand tools. Nothing too crazy about it. So, I hope everybody liked this. If there's any questions, comments, concerns, go ahead and leave them in the comments box. I'll get back to you as soon as I can. And as always, thanks for watching and have a great day. See ya.